This research is entitled Sansevieria Trifasciata, or snake plant as potential fertile pot. Fertile pot was known to be 100% organic and a biodegradable plant pot with no glues and binders and able to intact the pot. The general purpose of the study is to create and introduce an alternative fertile pot that highly advantages the locally existing fertile pot in the market, and also to provide people who are interested in planting and gardening, since the design fertile pot was intended for space-saver gardening. The independent variable in our study is the rate of decomposition, while the dependent variable of our study is the snake plant fiber. Also, we identified the extraneous variable experienced during the observation process, which is the changing weather condition. The qualitative nature of the study is the interpretation as well as the implication of the gathered results in the process of observation, while the quantitative nature of the study is the collected data and the use of various statistical tools such as mean, standard deviation, and ANOVA, enabled to give answer to the problem of the study and identify the significant value of snake plant fiber as fertile pot. This study determined the rate of decomposition of snake plant fertile pot compared to the locally existing fertile pot in the market. Also, the conducted study identified the effects of snake plant fertile pot when it decomposed compared to the fertile pot made from coconut fiber on the physical characteristic of the plant. In addition to this, the NPK level of the soil was also determined to support the significant use of snake plant fertile pot compared to the locally existing fertile pot in the market. This study utilized the stagnant water retting method and able to fully extract the fiber. Water retting method is a process where snake plant leaf was soaked or submerged in the fresh water for 3 to 4 weeks in order to fully extract the fiber of snake plant leaf. Also, the researchers utilized this method because it is the most useful and natural way of extracting the fiber. Also, vertical compression was utilized and able to mold the pot. Vertical compression is a process of making the fiber intact to each other and able to mold them easily as a plant pot. The researchers utilized this method since it's an alternative process of molding the pot. Based on finding in terms of the rate of decomposition, it shows that snake plant fertile pot has a success rate advantage of 1% compared to the coconut fertile pot after 3 weeks of observation. In terms of the effect on physical characteristic of the plant, it shows that snake plant fertile pot was more effective in contributing nutritional development to the plant when it degraded compared to locally existing fertile pot in the market. In addition, NPK level was also identified. Based on findings, it shows that snake plant fertile pot has sufficient content of nitrogen and surplus content of phosphorus and potassium. Based on findings and analysis, it justified that snake plant fiber is potential fertile pot. The recommendation of the study was to utilize the snake plant smooth leaf coat as a potential biodegradable plastic since it's accidentally discovered when we extracted the fiber. Also, snake plant fiber is a potential medical thread according to the conducted study of students from Cebu. The significant impact of the study is it introduced an alternative biocontainer that is fiber-based plant pot to the agricultural sector, especially to horticultural family. Since the design fertile pot made from snake plant fiber was intended as small space gardening. Also, it opened another source of income to local agripreneurs and farmers.